So Rohit, can you hear me and see the slides? Everything is fine?
Yes, I can see.
Okay, okay, fine. Then I'll get started. So Rohit, this is the first class on numerical methods for engineers. It is actually taken by the course instructor Niket S. Kaisare, as you must have seen all the lectures by sir. So we will get started. And to give you all an idea to what all happened in the first week, as sir has been teaching in the recorded sessions. So I've listed all the topics out here. So they will be introduction and motivation for this course, that is numerical methods. Why do we at all need numerical methods and why are we studying numerical methods? So along with that, the next topic that was introduced were error and approximations, followed by truncation and round off, then binary and floating points, then iterative methods, direct and sequential methods. Okay. So just to give all the learners an idea that who will be teaching, because we have two TAs for this course. So Rohit and I, as we just met Rohit Kumar Singh in the few minutes before. Rohit and I will be splitting the topics and discussing a few topics for greater interval of time, so that we could, clarify your doubts and discuss in detail on them. Okay. So to go about that, truncation and round off, binary and floating will be taken majorly by Rohit, which will come up in the next session, the 4 to 5 session. And the other topics like iterative method and sequential method, I will be dealing in detail. So it will be in this class. Apart from that, the other topics that you can see, Rohit and I shall discuss whenever it comes by. Okay, so this is the agenda for it is what was taught in week 1, and we shall get started with what we are going to do in this live session. So basically, the idea for the live class is that we will take up, Rohit, if possible, you could mute, there's some background noise probably. So you can unmute and speak up when I ask you anything. Okay, sure. So the agenda for this live sessions will be like we will take every single week. Like for example, this was the first week that is just over, right? From 25th to 29th, the first week was over. So we will start with a very quick revision. If at all there are any doubts from the lectures that probably it was recorded or anything that the learners want to ask the TAs. So we'll go ahead with a quick revision. And then we thought that we will take up the assignment of this week that you people are doing, and your deadline is coming in a few days. So we will take up those assignments and only take up the topics from that assignment. We won't be solving this current semester's assignment for you, because that is your task to solve it. So we will be going over all the topics and taking similar problems from previous year and solving it in front of you. Okay, so that in case in the recorded sessions you guys had any doubt in any step or anything, when I do it here step by step, you can ask me all those doubts. Okay. So that is the pretty much that is the plan for the live sessions. But what we would like to ask you learners is that, do you all have any suggestions as to how in other way we could conduct the live session? So you can unmute and just speak up if you have any other idea, how any other way that we could take up these live sessions.
No, this is actually, I think, pretty much a good idea. As of now, there are no further suggestions.
Okay,
We can go on.
okay, ठीक है. So the point is like, in case you had any doubts in the classes, any particular topic you wanted to know. So even that, while solving the assignment problem, I'll first go through the theory. So that's how I thought it might get covered. But anytime you all feel that you need any other topics to be discussed in live classes, please let us know. Okay. Okay, so I have kept one slides on what books you all can refer for this topic. So one of the books that is even suggested by sir is Numerical Methods for Engineers by S.K. Gupta, Santosh K. Gupta. It is one of the standard books that is followed in numerical methods. And another book that is Higher Engineering Mathematics. This is actually a book that is introduced to undergrad students. Okay, so mostly in this course, as we are expecting undergrad first, second year of students, and anywhere, any from any other discipline, any other year of their education, they can join this course. But since the most expected candidates are first, second year of UGs, this is one book that is introduced in undergraduate level. Okay, so if any learner wants to refer to any basic concepts that are being taught in this course, they can go back to this book. The PDF is available online and you can see the concepts from them. Okay. So, apart from that, this is one of the important things that I have to convey in this class is where will the recordings be available of all these live classes. Okay, so so we had to create our own YouTube channel, each of the PMRFs, and this is the URL given. So this message will also be conveyed to you all from the NPTEL side. I also kept it in the slides so that in case you miss out on any announcement. So you could go to this URL and the page will be there. And just like you can see, 2 videos are already there like that. Even today's video will be uploaded. Just to give a clue about what the second video of prerequisites is that we were told to record a dry run to understand how the recordings will be happening so far in the semester as the classes go by. So Rohit and I had to do a trial to understand how we would be going about all the recordings. And instead of just making it a dry run, we explained to the learners what prerequisites, like what subjects from school they can revise and come, so that this class is going to be probably they can connect better. Okay, so that is one video which is uploaded. You all can go through it, okay, whenever you find time. Okay? So we come to today's class, and in today's class the main idea is to take up a few problems, a few topics of the week 1 assignment, whose deadline is given to you as 10th August 2022, and we'll take up a few topics from this assignment and we'll solve it. So as I mentioned that Rohit and I are dividing the topics and we are going to solve, so similarly I am going to focus today on iterative methods and sequential methods. Okay, so with that we'll just get started. And so to get started, I need to have a recap of what are basically numerical methods and why do we need it. Okay. So all these techniques that I have listed so far, iterative methods and sequential methods, they all are numerical techniques, right? So if possible, could you unmute and just speak up about your idea? I mean, what do you think? Why do we even need numerical techniques?
Shani, actually, I could not attend the week one
Okay.
lectures because I was on official tour.
No
But what
problem.
I remember from my UG course that basically what are the series of so like we have binomial theorem or some series things are there,
Yeah.
and each time we are supposed to if we have some incremental value going on in some series or some velocity is going on or some any function is there where the series kind of thing is there, and next thing the value of next parameter is dependent on incremental value based on previous parameter.
Right.
Then there are various numerical series are there which are named by the mathematicians who found them, and the particular difference that on the basis of that there are various techniques to iterate that and to get the certain value of function at some certain given dependent on other parameters. It is like that.
Right. Excellent. I mean, you have explained actually a very high level of numerical techniques. So this
Okay.
is what we
Okay.
will be learning. I mean, throughout the semester, this is whatever you explained right now, we will be learning these throughout the semester. Okay. So what I will do here is to give you a very general idea. Like what if the students who just came from school, because you can understand, right? They are first, second year undergrads. So they have not heard about numerical techniques. So in that case, I'll just give you a very general idea that why are we even using numerical techniques. We were all good with analytical techniques so far. There was integration formulae, differentiation formulae, but suddenly why these numerical techniques are coming up? Okay. So one of the most simple, the reason why we are learning this is that always it may not be possible that you will always find exact solutions to all the mathematical problems. Okay, so whenever you, since you have the background, I mean you have done it in your job so far, that you will see that in real life problems you cannot get to the exact answer. Okay, so whenever these things happen that you cannot get to the exact answer, could you unmute? I guess there is a background noise. Yeah, thank you. So whenever these things happen that you are not able to get the exact answer, you try and approach towards the exact answer. Okay, and how do you go towards? So in school we have learned something like limit x tends to something, right? So x tends to something, or your answer going towards exact solution is basically called as going for approximate solutions. Okay, so since always in real life the problems will not be so simple and so easy that you can find exact solutions, we will go towards the exact solution and find approximate solution. This is the entire idea. Giving you one simple example of that, very simple example, as in 2 plus 2, we know it is exactly 4. It is not 4.0123, it is just 4, right? 4.0. But to take a very simple approximate solution might be e to the power 1. Now e to the power 1 is not just 2, it's not just 2.7, it is 2.7 and some other values which either need to be, we need to either stop it at a certain at a point, or we need to round off. So these concepts of round off, truncation will come about in the course. Okay, but as you can see by a very simple example that 2 plus 2 can give 4, but e to the power 1 is not a simple digit. This shows that sometimes there are approximate solutions to some mathematical problems. Okay, and that is what is the main motivation of this course, and we will go ahead with learning a number of techniques, a number of ways in which we are going to solve problems numerically. Okay, so with that I will come to the first question, that is the iterative methods. And for iterative methods, so do you have any doubts so far, Rohit? Are you okay with it?
No, it is fine.
Yes,
Going
okay.
good.
So I will just start with the solution. Okay. So for the first numerical problem that we will learn about is the iterative method, and this is one of the problems that Sir had taken in the classes, in the recorded classes, where he explained how can we find the square root of a number. Okay. So I will go to my writing pad and let me know if that is visible to you. Um, yeah. Are you able to see the writing pad?
Yes, yes.
Yeah, okay. So I will just start.
Which app is it? Is it
This is Notability.
Notable? Okay,
Yeah,
okay, okay.
okay. Just let me know if anything is delay, or if you're not able to see the writing part with my voice, hearing the voice. Okay. So what I'll start with is one of the algorithms that, okay, you can see, right? It's coming up. Okay. One of the algorithms that Sir taught in class, that is Henon's algorithm. And why are we solving the problem this way? Okay, so basically, just like I gave you an example just now, I guess there is a slight delay, but it will come up. Okay, just like I gave you an example just now that 2 plus 2 can come up to 4, but e to the power 1 will come up to 2.71 and a few more digits, right? Similarly, if you have to find out root of a number, suppose you have to find out root x. Okay, so if that root x is like root 4, you will be able to probably write it 2. We have learned it in school. But if it is root 2, what are you going to write? It is again a series of decimal numbers, right? So in this problem that I will be solving for you, I will show you how to find out root 5. Okay, with the help of this algorithm, which is known as Henon's algorithm. So if you see the class, Sir's recorded classes, Sir gave a very beautiful example of how Henon's algorithm has arrived or come up from history, that why people have brought down to a very simple formula which can help us to get the square root of 5. So in order to get, suppose let's say that x new that will come up is basically the answer to root 5. And how are we going to compute root 5 is half, that is the sign of root that will go into x plus 5 divided by x. Why it is 5 here? Because we are trying to find out the value for root 5. Okay, so we will try and understand how to go about this problem. So now you can, okay, I'll just have to position my yeah, can you still see the screen? Everything is fine? Can you hear me and see? Oh, okay. So now, okay. So now what we will do is, in the question, as if the assignment you must have seen, in the question it will be mentioned what value you are supposed to take at x equal to 0. So at when x is equal to, one second. Hello? Hello, Anurag. Can you hear me?
Yes, I can hear
Yeah.
you.
Okay, so because the time was running out, we had to start with the live session, but you will get all the recordings, okay? And do let me know if you have any doubts anywhere while I'm speaking.
Sure, thank you.
Okay, fine, welcome. So for you, Anurag, I'll just start from the beginning of this problem that I was just discussing with Rohit. And we would have, if you have seen the recorded lectures by Sir, Sir had taught an iterative method with the help of Henon's algorithm. Okay, so here we are just, and this is also one of the problems that is given in your assignment. So I was just going through how to solve the Henon's algorithm, an example for that. Okay. So in case you have to find root 5 using Henon's algorithm, and if the initial value that is given to you is x of 0 equal to 1, how are you going to go about the iterations? Okay, so we will write here. Are you able to see and hear me clearly, Anurag?
Yes, I can see
Okay.
clear.
Okay. So we will go about this. We'll write iterations and we will write what will be the updated value of x. So this particular step I have written so far. There's a slight delay, just bear with me. And then what would be 5 divided by x to the x of I. This is this particular step that I have written here. And what will be our new x equal to new, x new, and that value will get updated. Okay. So how to go about solving root 5 with the help of Henon's algorithm is that when we are at the iteration 0, it is given in the problem that the x of 0 is 1. Okay, and 5 of x will be 5. Hence, the new value of x is going to be half times 1 plus 5, which is equal to 3. So once you have this value of 3, what you will do is you will update this value of 3 at this position, and now we can start off with the iteration 1. So for the iteration 1, again we will repeat this. Hello sir, I can continue with the class?
Hi, yes ma'am, please continue with us.
Sure, thank you sir. Okay. So how are we going to find this? I will just erase this. Okay. So this is going to be 5 divided by 3, which is basically 1.666. I'll take it up to third decimal point. And again, how to find the x of new will be 3 plus 1.666, which is basically 2.333. So I'll just solve the steps and I'll get back to you all if you have any doubts in any particular step. Okay. Again, what we will do is we will update this new x new number to this xi value, which will be x 2.333, and again we will perform this calculation. 5 divided by 2.333, which is going to be 2.143, and when we perform this calculation, half plus 2.333 plus 2.143. I'm just not writing for the space constant perspective, but it will be the same that you have done in the previous two steps. The answer is going to come as 2.238. Okay. This was the second iteration. If you repeat this for again one more iteration, it is going to be 2.238, and 5 divided by this is going to be 2.236, and the x new value is going to be 2.237. So you will see that if you go on performing the iteration this way, like after 3, 4, 5, 6, if you go on performing the iteration this way, slowly and slowly this value is going to merge at the actual value of root 5, which is, I will calculate and tell, which is about 2.236. So this has almost merged, and you can see this particular error over here, that is 2.237, because you will see that we have already been truncating the value of the answer at particular stages. Okay, so that error will accumulate and you will see that these last few digits will vary. Okay, But this is how you will do the iterative method question in your assignment with the help of the particular root that is asked for you to find out. Okay, so here I have shown an example of root 5. So any questions or any doubts if you have so far, Rohit and Anurag, any of you?
See, we are trying to find the value of root 5. Then
Right.
why we have put initially as 5 there
Why
in
we have put?
Henon's equation?
So are you asking about this step?
Yes, yes.
Yeah, actually, you know what? This is the question that is given to us. We have not put it. So it is basically, I'll give you the idea. It's a very good question, actually. I'll give you the idea. See, if you're trying to find out root 2, can you see? I guess there's a delay again. If you're trying to find out root 2, it is going to be half here because of the root sign, and it is going to be x plus 2 by x. Okay. So whichever root you're trying to find out, that value is going to come here. So in order to give you a better overview, I will write one more step over here. If you're trying to find out root
If
a,
I'm if I'm trying to find out cube root, then it will be 1 by 3 x plus whatever the root I am
exactly,
trying to find out, that is divided by x.
exactly, correct.
Okay.
So I will give you the general.
And on first iteration, we have put x equal to 0. How we can get that value there?
So this particular value you're asking, right? How is x equal to 0 given as 1?
Yes, yes.
So this will be given to you in your question. So sometimes what happens is, like when we solve real life problems, suppose you're solving a problem in your project, you will see that you will assume a value. Okay, in that case probably you will make an educated guess. So this is what comes about, like when you solve real life problems, you try to predict that this might be closer to your actual solution, and you will assume a particular value. But it does not happen at the stage when you are learning. In this stage, even if you look at any books that I suggested, the SK Gupta book or Sir's recordings also, if you see, you will see always he will give, or the book will give, an initial value to start with. So you start with that and you proceed and see where you end up. Okay, so that's how it will be. And just to clarify, Rohit, I can write the general form over here. If you're trying to find out root a, square root of a, I mentioned that, what you will do is you will write 1 by 2 times, it will be x plus a by x. Okay, so whatever it is, if it is root 2, if it is root 5, it will go accordingly. And why this particular expression has evolved, if you want to know that, you can very well go and like see Sir's recordings one, because he's very beautifully given a graphical representation. But for your convenience and the other learners' convenience, I can just give you a small overview over here. So if this is a graph, so if I draw a x-axis and y-axis over here, so what you will notice is, suppose imagine the value of root 2 or a particular root a, let's just assume root a. Okay, suppose the actual value of root a lies along this line. Okay, if it lies along this line, it's a particular value, so it will go along the x-axis for a particular value of y, right? So if this is the actual value of x of root a, you will see that x and a by x, they will vary in both sides of the actual value. Okay, so probably a by x will start from here and x will start from here. So you will see that when you go, this is the iterations, the x-axis is the number of iterations. So this particular formula evolved in such a way that the average of this, so what are you doing by 1 by 2? You're taking the average of x and a by x. So the average of x and a by x will always lie in between them. So that is the exact idea of selecting why they, when they evolved the formula, the Henon's algorithm, why they had taken x and a constant by x. And when you take the average of that, it will lie somewhere in between them as compared to the initial values of this particular x and a by x. Okay. So that is the basic idea of Henon's algorithm. But if you go ahead, I mean, there might be other algorithms which might have predicted, okay, if we write the formula this way also, it converges, something about that. So we'll keep learning in the course. Okay, to start with, this is fine. Okay, so, is it clear, Rohit? Will that be okay? Anurag, any questions? I'm sorry, I couldn't relate too much because I already had started, but is everything
No, it's
fine?
good.
Okay.
No issues. It's great. Please continue.
Okay. So with that, so what I will do is, what I have actually done here is that for the convenience of the live class, I solved it for you guys. But I have also pasted the Excel worked out solution over here so that you understand if you want to solve it for a few more iterations and see that if I go on for like some 10-15 iterations, what happens, how well does it converge, you can follow the formula given here and you can find out, okay, in Excel. So the other method that we are going to see today is Taylor series. So as I mentioned, Anurag, for you, I'll just quickly mention it here once again. So today I'll be dealing with iterative methods and sequential methods, that is Taylor series. And just in the next class, that is the next session 4 to 5, another TA will be taking the other two topics. Okay. So I will go ahead and discuss with you a problem on Taylor series. So I will share the screen again and start writing. Just a minute. Okay. So can any of you just give me an idea that why are these techniques coming into the picture? Like we just saw an iterative technique just now, and in the recordings, if you have seen, if others of you have seen the recordings, then Sir had done direct method, sequential method, and iterative method is one of them. So can any of you just give me an idea that why are we evolving these techniques and what is the purpose of it in general? Any of you?
I think
To
the
get
analytics.
approximate value of
One by one, you
known.
can go. Yeah, okay, Rohit, go ahead.
Yeah, I wanted to say that we cannot get the analytical solutions for all the problems.
Right.
So for that, we take the approximate solution and we develop different algorithms.
Right.
Not we.
Yeah,
Our
I know,
ancestors.
I understand that. But definitely, exact, correct answer. Rohit, were you also saying along the same lines? Okay, so exactly. So that is the reason why, as I explained in the initial part of the class, Rohit, that sometimes, like most of the times in real life, we won't be able to get to the exact solution. And that is the reason why we go towards the exact solution and find out approximate solution. And for approximate solutions, we will always have techniques which will, not give the exact answer, but approximate towards the answer, right? So, here I just wanted to discuss with you that what is the motivation for these separate techniques. I mean, I get the idea. You all explained very well about why numerical techniques. That's fine, that's correct. But I'm saying iterative techniques and then direct method, then sequential method. Why are these coming into, like, have you given it a thought? I mean, I also don't know. I'm just asking, I'm just discussing with you that why sequential, why direct, why iterative? Like if iterative was there, then why did sequential come into the picture? So any idea you guys would like to share? Did you understand my question? I mean, it's
Uh, I think the method we follow will have the variable part of which, as we are solving this Henon's equation, there was some values fixed, but the approximate value of next decimal was going to change.
right.
The method we select, according to that, we will get to approximate solution for each problem.
Yes.
So, given the problem is, there might be another method which will be suitable for that particular problem
Exactly.
to arrive at approximate solution.
Exactly. So any points you would like to add, Anurag? This is perfect. I mean, Rohit, it's correct.
No, I agree with Rohit.
Yes. Yes. So basically, what happens is when we are going, we had iterative technique itself. So the problem that I'm going to solve for you now, we could have done by iterative technique also. But the thing is, as the problems evolve, like suppose we were seeing the square root of root 2, and now if we want to see e to the power x, try and find the solution for e to the power x, try and find a solution for sine x. So there are other techniques which can be used in order to go about finding the solution. Okay, so with that I will just start one more technique, which is sequential technique, and I'll come to it why is it in sequence and all of that, and we will see Taylor series. Okay, so Anurag, can you just tell me whether you have you were able to see the recordings and the background, because I discussed that with Rohit, so just wanted to know if you have seen the recordings.
Not really. Actually, I just wanted to learn this method only.
Right.
The Taylor series and Maclaurin series. I was not able to solve the assignment problem.
Oh, no issue, no
So,
issue. That's why we are helping you now, so you'll be able to go back and solve it. So I just want to know that, so I can take you from the basic. Otherwise, I will have an idea that they have seen the recording, so I can probably skip a few parts. So I'll go from the basic itself, okay, for both of you. So
okay, thank you.
welcome. So what we'll do is we'll try and understand Taylor series. Just let me know again if there is any lag or anything. So for to begin with Taylor series, first let's see what is the series. Okay, let's write down the expansion of Taylor series, which is a f of a plus h is equal to f of a plus h times f of a plus h squared times f squared divided by 2 factorial times f double dash of a plus h cube divided by 3 factorial times triple dash of a, and so on. Okay, so before I actually take you through the expansion, I just wanted to show you this one slide. I'll have to enable it here. Okay, so basically, if any of you have come across this book called as B.S. Grewal, so this is one of the book that is introduced after school only in the undergraduate level. It's the topic is the name of the book is itself Higher Engineering Mathematics. Okay, so since I also studied from that book in my undergrad, so I have kept a screenshot for you from that book. So if you are interested in going back and reading up how did this Taylor series suddenly come into the picture and what is its relation with what we learned so far and now that we are learning Taylor series and where all it can be used, so you can just go back once and refer to this book, the B.S. Grewal, and I've kept a screenshot for you exactly where it had started. So in Taylor series, what they actually tell is that in the expansion of the series, there are a few terms which will use the differentiated format of a particular variable. Okay, so that's why they first explain what will be dy by dx, what will be d2y by dx2, and so on. Okay, and they have represented that as probably y dash, y double dash, y triple dash, and so on. Okay, so the expansion of Taylor series can actually be taken up in this way that y of x, how to expand y of x as in the form of Taylor series is that we will write it as y naught plus. So y naught will be one of the values that's an initial value and it will be again given to you. Y naught plus some later point of the x value minus the x naught initial x value that was given to you times the differentiation of the function at that particular x initial value of x plus again the same thing, the later point of x minus the initial point of x the whole square divided by 2 factorial and so on. Okay, so this is how we actually learned it when in my undergrad just after school, how it was taught to us. And just a subtle modification of that process is what is there in the recording as sir has shown and the one that I'm showing you now. Okay, so I'm just showing you this so that you understand that it is there in the books and you can always go back and read it, but I will show you a simpler version which will help us to solve in the class. Okay, so I will go to my writing pad again. So what you just saw in the book as y of x can basically be written down as f of a plus h. Okay, and what is this f of a plus h? A is basically an initial value or a starting value that will be given to us, and h is basically a time step with the help of which you will go on doing the calculations. Okay, when I go ahead, you will understand. So, keeping that as the expansion, so this is the expansion of Taylor series. And why this expansion? Any idea? Anybody would just like to comment that why is Taylor series written like this? I mean, any thought? Are you muted?
HM getting h square and h cube exponential, we have to expand that also. So it's better we put only one value there.
Yeah, I'm losing you in between, Rohit. Can you hear me?
Yes.
Okay, yeah, you can tell me. I was losing you in between.
As per that original equation in both,
Mm-hmm.
expanding that x minus x0 on higher powers will become tedious.
Right.
So it's better to put only one variable there.
Right. You mean, are you referring to like truncating the series at this point and referring to them as errors? Are you referring to this point? Mm.
No, you asked it like means if I interpret your question
Mm-hmm.
correctly, you mean to ask why we have put that x minus x0,
Mm-hmm.
we have put h instead of that x minus x0.
Huh,
Is that
okay,
your
okay.
question, right?
No, I was not actually asking that. I was saying that, yeah, that's fine. That your h is basically x minus x0. That's fine. But I was saying that why is it written in this format? Like, any thoughts? It's a historical perspective. It's not related to maths or solving. It's a historical perspective. Why it is written in this format? So, in the interest of time, I'll just tell it. So the point, how this expansion has come about, no, it again comes from whoever has developed. I mean, how Taylor has developed this expansion, and hence we do not, like, ask the question here that why is the formula, why is the expansion like that. Okay, because any student might have this question, ki, first of all, why are you writing the expansion in this way? But the expansion has evolved this way, and we use it because in a lot of cases it comes and gives us the right approximate value of a few questions, of a number of questions. Okay, so we won't go into detail why the expansion is so, but I will go on solving the solution. Okay, so in order to solve this, we will take an example of sine of 0.75. Okay, so let's solve sine of 0.75. So how are we going to go about it? Let's first not take 0.75 in general, and let's, how much time do we have? Okay, it's 4. So we started around 4:10 or 4:15, no? So I'll just take 10 more minutes. Will that be okay? Okay, and then I shall communicate to Rohit and he could start. Anurag, is it okay for you?
Yes, yes,
Sure.
let's
Okay,
go ahead.
just 10, 15 more minutes. Okay. So let's see how, so let's not take 0.75 in the beginning. Let's write this problem in a general manner so that you can solve any other questions that will be given to you. So basically, f of x that we want to find out, we want to find out the value of f of x, which is basically in this case sine of x. Okay. So how are we going about and going to find out the value of sine of x? If f of x is sine of x, let's write one differentiate term of sine of x, that is, if you differentiate sine x, it is going to be cos x. Okay, and why are we only taking f of x and f dash of x? Because if you see sir's recording, very nicely sir has mentioned that from this term onwards, from this dashed line that I have drawn, from this term onwards, the values almost become negligible, and you can take them as truncation errors. So how much ever terms that you take up will actually contribute to the number of decimal values that will come in your final answer. Okay, so you can take, we will take only the first two values of the expansion. Okay, so let's go ahead with this. So what I will basically write it now is that let's write the problem f of x in terms of f of a plus h, because this is where our expansion stands. This is how our expansion is being done. Okay. So for f of a plus h, how will sine of x be written? Sine of x will come as sine of a plus h. Okay. Now let's see how to represent sine of a plus h in the form of this expansion. Okay. So sine of a plus h is going to be sine of a, because f of a is going to become sine of a. Okay. So this will be sine of a plus h times sine h times, okay, this is not going to be sine, h times f dash of a, right? And we have written f dash of x is going to be cos x, so f dash of x a is going to be cos a. Okay, so after this we will just use one trigonometric identity over here, that will be sine of a into h plus root over of 1 minus sine of a square. Okay, so basically cos a can be written as, this is just multiplication dot, cos a can be written as root over 1 minus sine of a the whole square. I mean this, it will be sine a square. Okay, so after this, why are we writing this? So you might have a question, why suddenly from cos we are again changing to sine? Because I want to write this entire equation that I've written so far in terms of f of
In
a.
terms of sine only.
Yes, only in terms of sine, because I want to revert back to f of a. I want a general expression. Okay. So what I will do here is that sine of a plus h is equal to f of a, because sine of a is f of a. Do you want me to write that? Okay, I'll just write it. If f of x was sine x, so f of a will be sine a, and f dash of a is going to be cos a. Okay. Hello, Snehal. Can you hear me? Snehal, can you hear me?
Yes.
Yeah. So actually there are two live sessions, one from 3 to 4 and 4 to 5. So I will be ending the live session in just a few minutes, and the other TA of the course will start in a few minutes. Okay. So both the sessions will be recorded. So don't worry if you miss out on a few sessions in the beginning of the classes. Okay.
Okay, sure.
Yeah, sure. Okay. You can just continue listening to it and get back to me if you have any doubts, because I'm telling you from the between of the course. So just get back to me. Okay.
Okay.
Okay. So how do we write in terms of f of a now? This will become f of a plus h times root over of 1 minus f of a ka whole square. Okay. So with this expression that we have written here, let us substitute the values. Now we just saw before some time that the Taylor series is basically a sequential method, right? Why are we calling it sequential, and what is this h value? So h value is basically the step or the size of how are you varying from one particular, when you're doing it again, when you're solving the equation in sequence, what particular size are you taking in that interval? Okay, so if you see sir's recording also, sir has explained this in a very detailed manner. You can just go through that once. So what I will do is, once I will try and solve in a one step process, that is sine of 0.75. I will solve. How will I solve in one step process? I will directly go from sine 0 to sine 0.75. Okay. So in order to solve that, what I will do is, I will write sine 0.75 as sine 0 plus 0.75. And why am I writing this for you? Because I want you to understand that this takes the format of sine a plus h. Okay, where your a is 0 and h is 0.75. So next, if you solve this in this particular expansion, in this format, if you solve it, what you will get is uh, sine of 0 plus your h value in this step 1 is 0.75. Why is h 0.75? Because you can calculate this value of h as suppose, okay, one second, if I'm confusing you all, you can just ask me again. Our initial question was sine x, right? So imagine your x value is 0.75. Okay, how to find out h, or the time step? That is, you will divide this x value by in how many steps you're trying to find out the solution. Okay, so since we are trying to find out the solution in just one step right now, your h value is equal to 0.75. Okay, so now we will write sine of 0 plus h value is 0.75 times, the next is root over 1 minus sine 0's whole square. Okay, if you find out, if you solve this, it is going to be 0 plus 0.75, which is ultimately going to be 0.75. Okay, so what now next what we will do is try and solve it in a particular sequence. So we will try and solve it in a step 3 sequence. Like we will take 3 steps to solve this particular problem of sin x. Okay. And how do we do it in 3 steps? That is, sine of 0.75, where your x value is 0.75 and your h value is 0.75 divided by 3. You're trying to solve it in 3 steps, right? So basically from 0 to 0.25 you're taking, from 0.25 you're taking to 0.5, and from 0.5 you're taking to 0.75. Okay. So when you do this, you will get 0.25. Now we will use the h value as 0.25 and solve the problem. Okay. So for that, your h value is 0.25, and how will you write sine of 0.25 as? It will be sine 0 plus 0.25, which, so I'll just go on, I'll finish this, and after this you can ask me any doubts, okay? Because in between it will be anyways confusing to ask. So, so sine 0.25 is going to be sine 0 plus, your h value was 0.25. Your h value was 0.25 into root over of 1 minus sine 0 whole square. Okay. When you solve this, you're again going to get 0 plus 0.25, which is equal to 0.25. This was your step 1. Now you will do step 2, in which you will find out sine of 0.5, in which you will use the previous value of sine. Okay. And how will you solve that? Sine 0 plus 0.5. Remember, why I'm writing it in this format is because I'm resembling our question in the initial expansion format. Okay. Sine a plus h. So this will again be sine of 0. This will now be sine of 0.25, because you will always use the previous value. Okay. So this is going to be sine of 0.25 plus, your h value is 0.25 into root over of 1 minus sine of 0.25. Okay. So how will you solve this? You have just found out the value of sine 0.25 is 0.25 plus 0.25 times, you will do this calculation. Okay, I missed the square here. There will be a square here. Square inside. Okay. So if you do this calculation, it is going to be, I'll write the answer directly. We are running out of time. The answer is going to be 0.492. Okay. After this, you will solve for your actual question, that is 0.75, and you will use this previous value. So for that, sine of 0.75 is equal to, yeah, Anurag, do you want to say something?
Yeah, the last one,
Yeah.
will it not be like sine 0.5 plus 0.25?
Which one? Which step? The last
For
one.
finding sine 0.75.
Yeah. You mean at this step?
Yeah.
I didn't. 1 second. So this will be sine 0. This is. Oh yeah, you're right. Yeah. So what you're saying is, this is so this one also there is a mistake, is it?
Yeah, it should be sine 0.25 plus
Yes.
0.25, right?
Yes. This is going to be 0.25 plus 0.25, and that's why it is going to reach up to 0.5. Yes. Sorry, that was a mistake. Thank you for pointing that out. So it means that when I will solve this step, it is going to be sine of 0.5, which was at the previous step, plus 0.25. Is it correct now?
Great.
Yes, because the A value changes. Yeah, perfect. So because I'm sorry to confuse you, Rohit, because the A value here, suppose this was the A value initially, right? And hence it was 0 here. So in the next point, the A value has updated to 0.25 and hence this is the A value. Again, as he pointed out, now in this form, this is the A value and hence we'll continue with 0.5. Okay. Sorry to confuse you there. Okay. So this will be sine of 0.5 plus 0.25 times root over of 1 minus sine 0.5 square. Okay, so when you solve this, the final answer is going to come around 0.709 about. Okay, so if you actually find the real value of sine sine 0.75, it comes a little different from this, because how many ever time steps you take, if you even take a time h value, like here I took the h value as 0.25, right? If you take an even lesser h value, you're going to get a much more accurate solution. Okay, so because you have updated the value in the previous one and you are calculating the next value with the help of the updated value. Okay, so these were the two problems that I thought of discussing with you. And any doubts so far? I mean, in Taylor series or in iterative, any of you? Do you guys have any more doubts in these two techniques?
Methods are pretty clear. I just forgot why it is called iterative and why it is called sequential. I missed that part.
Yes, fine. I'll come to that. See, I will come from here. Good question, Rohit. See, I'll come from here. So, see, when you are solving the problem with the help of iterations, that is, in your first iteration, you compute a value of xi, you compute a value of 5 divided by xi, and you get a new value of x. And that value of x gets updated, and you perform a second iteration with that updated value. Okay, here there is no concept of time step or something that is adding up in sequence. It is just that in the 0th iteration, the value is given to you in the problem. In the next iteration, the previous value is used, but it is a completely different new iteration. Okay, there is no concept of time step in this method. But when you come to the sequential method, when you come to the Taylor series or the sequential method, what you're basically doing here is that you are taking a specific time step which is telling you how is your next value and the previous value differing from each other, and using that you are finding out the next value of the the solution, the next solution basically. So when you're using a time step, you are going ahead in sequence. That is, try and understand it from here. Like in step 3, you initially started with a value of 0.25. From 0.25, we went and computed a value of 0.5, and then we computed a value of 0.75. We went in a particular sequence. We could not come, so these are not iterations. It is not in the first iteration, second or third, but this is in a particular sequence of 0.25. Okay, there is another student. Okay, so hello Vignesh. Hello Vignesh.
Hello.
Yeah, hi. So just give me 2 minutes. This session is just about to end, the 3 to 4 class, and it's all recorded, so you will get it. And the other TA of the course will start the class from now on. Okay, so you can attend his class live and see the recordings for my class. Okay, and next time you can join if you're free from 3 to 4. Okay.
Where will be the recording?
The recording will be available to you. It will be there over YouTube, and all this information will probably be given to you via the NPTEL portal itself. And it's there in the slides that I have shown today. So give me some time after the class. I'll figure it out with NPTEL and come back to you all. Okay, how you will be accessing the document, my write-ups, and the recordings. Okay.
Okay, thank you.
Okay, welcome. Fine. So so Rohit, did you get the idea about why it being in a sequence and being in iterations? But I guess I will try and find a better understanding to this, that how is it in sequence and how is it in iteration, and try and get back to you. Okay, like I'll try that if I can explain it better. Okay, Apart from that, Anurag or anybody, any other doubts for this session?
Great session.
Okay,
Thank you.
fine. Okay, fine. So one thing first I need to do is stop the recording, and then I will